Imagine a world where a single invisible mistake can cause chaos. A medical device fails mid-operation. A self-driving car loses control. Or a critical device handling millions of users crashes.
You have failed me for the last time.
Behind the scenes, these disasters often come from memory bugs, race conditions, and hidden security vulnerabilities. Problems programmers have battled for decades. Before Rust, developers relied heavily on languages like C and C++, which were powerful but unforgiving. One small mistake could ripple into catastrophic consequences. Software systems were fragile, unpredictable, and at the mercy of human error. For users, the result was frustration, lost data, or worse, security breaches, exposing personal information. The digital world we take for granted was vulnerable. Who faces the darkness? Here enters Rust. The Rust programming language was created by Graydon Hoare and developed by Mozilla with a vision to combat software fragility. Today, it is used by system programmers, back-end developers, and game developers in major companies like Microsoft, Amazon, and Meta. Even if you don't write code, Rust is shaping the apps, games, and devices you use every day. It's the silent guardian, preventing crashes, data leaks, and security threats behind the scenes. Microsoft, for example, is actively exploring using Rust to replace legacy C, C++ code in major projects, a step that could prevent countless errors and widely used software systems. What brings the light? Rust focuses on solving critical software problems with three core principles: memory safety, ensuring programs do not crash due to hidden bugs without relying on garbage collection; high performance, running software efficiently without sacrificing speed; concurrency safety, allowing multiple tasks to execute at the same time safely without chaos. Think of Rust as a high-tech safety system in a skyscraper. Steel beams that never bend, floors that can handle multiple workers simultaneously, and invisible safeguards ensuring everything stays upright. Rust brings stability and reliability to an otherwise fragile world. When Rust steps into the light. Rust first appeared around 2010, and in 2015, it reached its first stable release, Rust 1.0. Since then, it has continued evolving, with regular updates every 6 weeks, keeping it relevant, modern, and strong against emerging software challenges. This steady evolution ensures Rust adapts to new technologies and platforms while maintaining its core promise: safety without compromise. For developers and users alike, this is the difference between a system that fails unexpectedly and one that performs reliably for years. Where Rust protects us. Rust's influence spans multiple areas: operating systems, forming the backbone of devices and servers; web backends, powering websites and online services; embedded systems, running on chips in cars, applications, and smart devices; game engines, helping your favorite games run smoothly; command line tools, boosting productivity and enabling automation. Rust runs on Windows, Linux, Mac OS, and even embedded devices. Its adoption in Linux kernel development marks a major milestone. The foundation of computing systems is being made safer, faster, and more reliable thanks to Rust. For whence Rust came. Rust's story begins as Great and Hoare's personal project, later nurtured and grown inside Mozilla. It drew inspiration from C++ and ML and functional programming concepts, combining the performance of older languages with modern safety. Rust is like a classic car engine, rebuilt with modern safety and efficiency. It retains raw power, but eliminates hidden dangers that could cause catastrophic failure. Its design philosophy is rooted in learning from past mistakes, a guardian born from the chaos of older software systems. Whither Rust moves. The future of Rust is bright and essential. System-level replacements for C, C++ promise safer, faster software. WebAssembly adoption allows Rust to power high-performance apps and browsers safely. Safety-critical software, from aerospace to finance, increasingly relies on Rust guarantees. For everyday users, this means fewer crashes, more reliable devices, and safer apps. Rust is no longer a niche language. It is a solution to real-world problems, protecting the digital world from the dark side of unstable code. Why Rust matters. Rust exists to fight the hidden threats that threaten software systems, preventing memory bugs that cause crashes, avoiding security vulnerabilities that could compromise personal data, delivering high performance without sacrificing safety. Every program written in Rust is a small victory of light over darkness.